Oh, goodness, look at that. I'm still working on my slides. Last minute. Hi, everybody. Woo! Good stuff. We made it. Look at us. We're at the end of the day. What day is it today? I don't even know. Wednesday. Good stuff. Welcome. Come one, come all. Have a seat. Relax. Take your load off. It's going to be fine. Hey, we got a lot of stuff to cover. I'm super happy to be here with y'all. Can we take a photo? Yay. Okay, good. Okay, just, okay, 1 second, okay? Okay, everybody, you know the drill. You're going to say, open source. I'm going to take a photo. Pretend to be happy, okay? Ready? Ready? Open source. Very good. Thank you. Thank you. Thank you so much. I appreciate that. I'm going to do as I always do. I'm going to take that photo and I'm going to show it to my daughter and I'm going to say, see, they listen to me. That's a Chris Richardson joke. I love that joke so much. My name is Josh Long. I work on the Spring team. I'm here at your service. I'm very online. I've got a YouTube channel, and there's code there, my Twitter handle, and all that kind of stuff. My friends, it's an amazing time to be a Java developer. Perhaps you've sensed that just being in this show, listening to all these amazing talks. It's an amazing time to be a JVM developer, right? To be somebody on this platform. We live in an age of unprecedented gains in technology, and all we have to do is upgrade. And I think Spring is a natural place on which to sort of build upon all these innovations. And so we're going to talk about all these amazing features today, my friends, with the core thesis ultimately being that there's just never been a better time to be a developer on the JVM. It really is an amazing, amazing time. And I say that fully aware of the incredible history that Spring itself has had. Did you all see this? I love this. We created this for Spring 1, our little conference there. It's the history of Spring. So this year we celebrate 20 years of Devoxx. Hooray. Congrats. Happy birthday, Devoxx. I'm a big fan. But we also celebrate 20 years of Spring, right? Since the early access builds of Spring Framework came out. And so we created this little cartoon. It's spring1.io/history of Spring. And, it's a little finicky, right? Rod Johnson publishes the book addressing J2EE complexities, 2002. I'm going, there we go. Yep. Whatever. Moving on, I'm going to fast forward. Lots of stuff here, okay? I'm not going to sit here. We're in the clouds, by the way, in case you didn't see that bit right there. So that's the cloud, right? There's the cloud. And Spring Cloud, get it, 1.0. Okay, got it, good. Coin, good. Going back down. There's water, Kubernetes, right? Spring Cloud Skipper and Kubernetes and Spring Cloud Gateway for Kubernetes and all that kind of stuff. Look at that, right? So there we go. So 20 years of Spring Framework, and now we have 10 years of something called Spring Boot, right? It's just an amazing time, and these technologies stay amazing because they stay relevant, because they stay up to date with the latest and greatest in the Java ecosystems. There's a symbiosis there. There's this thing that both of them can do. There's different waves that we ride, and it's just an amazing time. So, my friends, I want to show you all this stuff. I want to show you all the latest and greatest in the Java ecosystem and in the Spring ecosystem. So we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You too should love production. But we're going to go here. We're going to join a new project using Maven because right now, Gradle and Java 21, they're not great together. I'm sure it'll be fine in a bit. But for now, Maven. Now, my New Year's resolution this year was to use and to learn Gradle and to lose weight. And, the Gradle's going well. It's going well, okay? But for now, I'm going to use Maven, okay? And then we're going to use Spring Boot 3.20 M3. This is a milestone, okay? And then we have a choice about what we want to name our service. Friends, I'm going to name the service Service. And the reason is because I'm really good with names. I'm amazing with names, okay? I get that from my father. My father was also amazing with names. We had a small white dog when I was a child, and my father named him White Dog. Now, this dog disappeared after like 10 years. I don't know what happened to him. Maybe he got a job. Anyway, another small white dog appeared magically at the front door looking for a little home, and then my father named him Two. Now, I don't know if it's TWO or TOO, but either way, he's great with names, and I get that from him. But my mom, she always tells me, "You're lucky that I named you," and I think, yeah, that's probably true. So We're going to also use Java 21. My friends, there are 4 radio boxes down here. 4 radio boxes looks like you could select. But friends, only 2 of these are valid choices. You see, in order to use Spring Framework 6 and Spring Boot 3.0, you need to use Java 17 or later. Okay, so these other 2 radio boxes, these are just for the memes, just for the lulz, just to find out who makes terrible life decisions. You should never select these ever in any context whatsoever. They're completely inappropriate in all situations. Java 17 and later are technically superior in every way. They're faster, more robust, more syntax rich, more operations friendly, more secure, more container friendly. They're also morally superior. You won't like the look of sadness and shame in your children's eyes when they find out you're using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing. Use at least Java 17 or later. I'm going to use Java 21 because judging purely by the version number alone, I think we can agree Java 21 is almost 3 times as great as Java 8. It's an amazing, amazing release. So, friends, we're going to add some dependencies here. We're going to add the web support, the actuator support, the GraalVM-native image support, the DevTool support, the Postgres support, Testcontainer support, the data JDBC support. Okay, so I've got a number of different dependencies here: web, actuator, native, DevTools, Postgres, Testcontainers. I think I'm happy with that. I think I'm satisfied that I've got everything. Whatever, we'll figure it out later. Good. Hit generate, and that's going to give us a zip file that I can open up in my IDE. Okay, and I'm going to be using IntelliJ, but it doesn't really matter what you're using, so long as it supports the IDE that you want to use. So I'll go ahead and open that up. Okay. Oops. I use the Barbie theme, don't you? So let me put the sync with the operating system. It's better for my programming mojo, but when I'm on stage, I'll go back to the regular one. Okay, so we have our public static void main. By the way, the Barbie theme is really good. You should try it out. It's really, so at first it was kind of a joke, and it's like, actually it's fine. It's great. Try it out. Okay, so public static void main. This is where I want to start building my application, but I want to live that git clone run life. I want to take my code, make changes to it, and start working on it immediately. I don't want a wiki page with 500 easy steps to development. So I want to be able to start working, and I don't want to have to set up all this machinery just to get things going. So I used Testcontainers. I selected Testcontainers at start.spring.io, and what that did was it generated a public static void main application in the test code here. So test Java, com example, blah, blah, blah. And you can see it's a public static void main class. It's got public static void main. It's going to delegate to the actual production code, which we just saw, but it's going to actually augment that configuration with this extra bean, a test container bean, okay? And even better, we've told Spring Boot, hey, I'm going to connect to this Postgres. I just want you to figure it out automatically. That's what the service connection thing is. We're also going to use DevTools. DevTools is a great way to make changes to your code and then do live reloads while you're working. And the idea is that it's going to not restart Java. It's going to keep the JVM running, but it's going to restart the Spring application context each time. This is great because Spring restarts really quickly, but the JVM can be a little slow to start up on each restart. And this is normally a rock-solid like plan for moving quickly, unless that is if you're starting a Docker image for Postgres on every restart, right? That's going to be a fly in the ointment. So I want to tell Spring, hey, don't restart the Postgres container. Let that run, and let that endure, let that survive each restart. So I'll use @restart scope, okay? Okay, so now I've got this. I'm going to go ahead and run this application. Here we go. Go. Hurry up. Compiling. Okay, good. So this is going to take an achingly long time, and the reason is because it's going to download a Docker image and all that kind of stuff. But you can see it's already figured out the connection. We're off to the races. It took 3.68 seconds, okay? Now I can go to my service application, my actual application itself, and we can start making changes. So here's service application.test. I'm going to go down here. I'll build a record, right? I'm going to build a data-centric application. It'll be a customer. I'm going to use Spring Data JDBC. There we go. And by the way, I'm using a record here, right? I love records, right? Just an amazing feature, right? And it works well. It works really nicely with some of the new stuff. I'm sure you've heard discussions around data-oriented programming, sealed types, pattern matching, all this kind of stuff. There's just a nice confluence of features. Okay, we're going to create a customer repository. Okay, extends list of CRUD repository managing entities of type integer, of type customer whose primary key is of type integer. And then I'm going to create a customer HTTP controller. Okay, and I'm going to inject the customer repository. Here we go. Voila. Good, good. Enter. Good. Okay, there we go. I'm going to say at controller, at response body. And there's my basic controller. We're going to create an endpoint here to handle requests. So customers, collection of customer. Good. Return this dot repository at find all. Okay, pretty stock standard stuff. I need some data with which to work, so I'll go ahead and initialize that here. I'm going to create a file called schema.sql, which will have the data that I want to work with. So I'll say create table if not exists customer. Okay, my DDL, got an ID, I've got a name, I've got my this. Okay, good. Okay, and I want some sample data with which to work. So I'm going to put some people in the Spring team in this database. Okay, so delete from customer, and then we'll say insert into customer. I'm just going to put some names. Okay, just some names from the Spring team. My name is Josh. It's so lovely to meet you all. We've got others. We got Yushin. We've got Jurgen, of course. Whoop, wrong one. Uh-oh. Hold on. No. Don't worry. I got this. They moved it for Jurgen. Okay. Olga and Sebastian. Sebastian. You got to be a little impressed that I can even do this. Okay. Okay. Madura. Here we go. Who else? Violet. Huh? Spencer. There we go. That's 8 records, okay? So the nice thing about that is it's 8. You can divide it by 2 and then 2 again. It's still 2. It's just very satisfying. I'm a big fan of that number. So I'm going to go ahead and now initialize the database. We're going to say, please run the schema to initialize the application on every single restart. And then I'm going to hit Command-Shift F9. That's going to do a recompile, which again, will just trigger the restart. So there we go, 0.3 seconds to get that going. Now I can go back to my console or my browser, localhost, customers. It worked. Of course, it worked. It was a demo. It was always going to work. There was no doubt. So let's go back here. I'm going to create a new endpoint. I'm going to say customers / name collection of customers by name, path variable string name. I'm just going to return this, and I'm going to say find by name. But you can see the problem here, right? This method doesn't exist. So I'll let the IDE and have it do the walking. Take that, ChatGPT. Did you see that? That was awesome. So we go here, localhost Josh. Okay, there we go. It's worked. Good stuff. So we're moving quick. We're doing live reloads. We got git clone run. We got Testcontainers. We got Postgres. We're making progress pretty quickly. I'm using that gloriously simple, concise syntax with records. I've got my persistence layer going. Good stuff. This is all pretty stock standard stuff. The difference, of course, is at this point we're just moving a lot more quickly than you might have, 10 years ago, for example. But we haven't stood still. Right? There's all sorts of new stuff happening in the ecosystem, and of course, we want to support that as well. So one thing I want to do is, and also remember, one thing I want to do is I want to make my application sort of just a bit more intelligent, right? And so we have a project that we announced about a month ago called the Spring AI project, okay? And so I'm going to take this data, and we'll just go to the build here, and we'll just paste that in. Voila. Get rid of that. Get this repository. Put that way down here, okay? So if you look at the dependency, it's the new Spring AI project, right? It's an experimental, super important here, okay? Experimental Spring AI starter. In order to configure this, obviously, well, first of all, I have to restart it because that's a class path change, right? That's not just a code change. I've actually added things to the class path. But in order to configure it, you need to configure the OpenAI key. Well, of course, I've already got that as an environment variable. I've done the equivalent of this, right? I've exported the environment variable as a key in my local machine. So you forgive me if I don't leak that particular credential for you. Just trust that it's done, okay? Good. So now I've got this thing here. I want to make changes to the code. It's already ready. Let's go ahead and create a new controller like this. So we'll say at controller, okay, class, at response body, class AI controller. I'm going to say private AI client, okay? Voila. There you go. I'm going to call this singularity. Good. Inject that into the constructor. And we're going to create a little story here, just a little story. Okay, what could go wrong? We're going to ask it to tell us a story about No. Did it? Come on, do the thing. Because then we're going to tell it to tell us a story about the delicious food here. Okay? So story, gesund, singularity, dot, generate, and here, prompt, voila, okay? And I'll say, tell us a story about the delicious food in Belgium, and do it in the voice of famed children's author, Dr. Seuss, one of my favorite doctors. Okay, one of my favorite doctors. So we're going to go ahead and use that prompt, and we'll generate that. And this is actually going to give me a response like that. Okay, it's a generated value. I'll just store it as a variable. Command Shift F9 to recompile. Go here, and we'll say story. Okay, and we're going to let it talk to the cloud. The internet has not been so indulgent today, so we'll see what it does. If it does anything, who knows? This I don't know why Safari is giving me this particular emoji. It knows a thing that I don't know. Okay. Once upon a time in a land far away lived the Belgians. Oh, how they loved to play. But more than playing, they loved to eat. Their food was a treat, oh so sweet. Now Belgium was known for its tasty cuisine, with dishes so delicious, fit for a queen. There were waffles and chocolate so rich and divine, and mussels and frites. Oh, they were simply fine. In the mornings, they'd wake to the smell of warm bread, with fluffy croissants, the best, it was said. They'd spread on some butter and a dollop of jam, and feast on the goodness like a hungry little lamb. Anyway, you get the idea. It can write poetry. That's cool. Neat-o. But one thing you might have noticed is that when we were doing this, it took a fair while, didn't it? We made that request, and we just sort of sat there waiting for the response. I've just triggered another request. Who knows if it'll actually arrive? Here we go. Give it a second. It's just taking a little while, right? And you have to appreciate that. There's actually a fair bit of latency here. Now, what's happening from the perspective of the user when we make this request? Well, they're sitting there waiting. But even more troubling, what's happening from the perspective of the runtime when we make that request? Well, we're sitting on a thread. This request is being handled by a thread, and we're asking for that response. And behind the scenes, there's some input streams and output streams and other blocking things, right? Where it's said to be blocking. That is to say, we're sitting on the thread waiting for something, but we're then just spinning. We're doing nothing while we're waiting for that response to come back. This is a bit of a problem. In the past, there have been ways to sort of get around this by using non-blocking I/O, like Java NIO and Java NIO2 and so on. This is low level, so people used sort of higher order abstractions, things like reactive programming to get around this. But if you, in this case, don't have access to that, well, what are you to do? Well, of course, now we have an option, right? How many of you have seen some of the amazing stuff that's possible with Project Loom this week? Oh, Loom is really, really good, right? One of my favorite examples here from José Pomar. He's a developer advocate on the Oracle team. He has this great example, which I'll just shamelessly pilfer here, where he talks about, like, okay, let's say you wanted to create a bunch of threads, okay, and we're going to create contention. And so for each index, I'm going to say thread.ofVirtual.unstarted, and I'm going to pass in a runnable, and then I'm going to turn that into a list. So there we go. I'm going to say for var t threads t.start, and then start.join, okay? So there we go. We're going to mute that. That's a nice thing to do. Good. So I'm going to do that. And then what I want to do is for each thread, I also want to keep track of what threads they're on. Okay. So new concurrent skip list set var observed equals this new concurrent skip list set string. Voila. And now I want to observe it. So I'll go back to here. I'll say, okay, static string observe int index, and we'll say if index should be 0, so it's the very first one, then capture the current thread to string, otherwise just an empty string, okay? But we want to do that only after we've slept a little bit. That's a blocking operation. And the reason we want to do this is because the runtime is going to see that this thread is doing something that is, we're just not doing anything useful with the thread. It's going to free up the thread and allow other parts of the program to repurpose that thread. And we'll see that that's true by then observing the current thread on which we're executing when that program returns, when that method returns. So we'll say observe.add, observe, right, passing in the index. And we'll just do that 3 times, okay, or 4 times. So now we got this. We got the observed. Let's just print out observed.toString. Command Shift F9, go to the console there, and when the application starts up, you can see that the program ran on the same virtual thread 120, virtual thread 120, virtual thread 120. So the first thread of all the 100 that we created, the first one was on virtual thread 120, but the actual thread changed. Worker 4, worker 6, worker 9, worker 7. And that all happened transparently. We did a thing that blocks. But behind the scenes, it moved us from one thread to another and moved the blocking code into RAM off to the side so that that thread was available for somebody else in the system to use. That's amazing, right? And so all you got to do, you saw it was pretty easy. All you have to do is change the thread type, right? I created a thread here with a virtual. If you're using a thread pool, well, don't, right? Don't use thread pooling with Project Loom. If you're going to do something, use the new executor, right? var e executors dot new virtual thread per task executor. That's what you should be using instead of what I was using, okay? But even there's a lot of places in a typical Spring application where you need to plug that in, right? And you're doing web processing, you got integration, all this kind of stuff, messaging, all that kind of stuff requires a thread pool of some sort or an executor of some sort. Well, in Spring Boot 3.2, coming out in November of this year, you can just set this property and we'll do that for you. So now we will automatically delegate to Loom-based executors for you, which means that now you have unparalleled scalability. You can now handle workloads akin to using the servlet async API or reactive programming API without having to change your code. Just set this property and enjoy. Okay, so that's a nice thing. We got that now. What else can I do? Well, I've got this application. I think I'm ready to start thinking about moving this thing to production. And here, friends, there are a number of things that we have to care about. First of all, how do we package the application in such a way that it's going to do its best in production? Obviously, I need to containerize it. Well, this is a very simple problem for it. Is a very simple answer, right? Buildpacks.io. This is a not new technology. It's a Cloud Native Computing Foundation specification for containerizing applications. I'm not going to show you that, but basically you can use the pack CLI to pack any application, be it a Ruby on Rails or .NET or .war or .jar or Go or Node or anything, even I can't say it, it's not a language, but if you could use it, if you could say that, then you would be able to use that with this as well. So that's all well and good, but obviously Spring Boot has support for it out of the box, so we don't need to do that. You can go to the command line here, for example. There we go. And if you're using Maven, you could say Maven Spring Boot build image, I think. Yeah, that one. Do that. Or if you're using Gradle, you'd say Gradle w build boot image, I think, right? Either one, that'll do the job. But, that's neither here nor there. Let's not bother with that. That's interesting. But what I want to do is I want to package my application up in such a way that it's as efficient and scalable as possible. And here, friends, it's worth stating, it's worth reiterating that Java is already very, very efficient, right? It's just a really amazing piece of technology. And I think that's best epitomized by this paper that was covered in this blog back in 2018, before the COVID pandemic, BC. And this blog, this paper, asks the question, which programming languages use the least electricity? And friends, the numbers are pretty astonishing, right? So let's open this address up. Here we go, paste. Here we go. We can see, if we look at this table, that for the normalized global results for energy, time, and memory, C is number one. It is the most efficient for machines. For machines, not for people, definitely not for people, for machines, okay? Super important that we're on the same page about that. Rust coming in, zero cost abstractions, good stuff, well done. C++, tooey, disgusting, moving on, don't even care. And then Ada, but nobody uses that, and then Java, right? And Java is in the top 5. For simple math, okay, friends? Let's say that's 2.0. We're going to round up a little bit, okay? Doing quite well, top 5. So we've got Java, top 5. We've got other languages. We've got Fortran and Swift and Haskell and C# and Go, Away and Dart and JavaScript. What is going on here? Why is this 4 or 5 times worse than that? I thought this compiled into this. You would think a little structure and compilation would help this, but no. Somehow, these numbers, they defy description, and so I will not try. Then we have these disgusting languages. We'll not even, nope. Moving on. Then we have this. Look at what's going on here. JRuby is Ruby, an interpreter written in Java. Ruby is the Ruby interpreter written in C. And the Ruby interpreter written in Java is like 1/3 more efficient than the Ruby interpreter written in C. That's an amazing number right there. That just shows you what an amazing piece of boss-ass software the JVM is, right? Just by virtue of having written it on top of that, you get this incredible, incredible performance. And then this. And this really, really makes me sad, my friends, because I love Python. I have been using Python since the 90s. Bill Clinton was president when I started learning Python. And this is not great, right? That's 75.8. Let's round up, okay? Let's say 76, okay? That's, so what is that? If you divide it by 2, I'm not very good at math, but you know what is good at math? Python, yeah. So 76 divided by 2 is 38. So what that means, friends, that means is if I wrote a program in Java, and that program resulted in a little bit of energy usage, and that energy usage in turn resulted in some carbon being emitted into the atmosphere, which resulted in a little bit of pollution, which in turn killed 1 tree. That same program in Python would kill 38 trees. That's a forest. That's a problem. That's like Bitcoin. That's just disastrous for our planet, you know? Save the turtles. Don't do that, right? So not good. We got to do better. Not good. I don't know what we're talking about, though. I forgot. Oh, yeah, Java. Really amazing, amazing software, okay? My point is it's just really quite good. It's very, very good software. So when I say all this, just remember, I love Java. I cannot believe how amazing it is, and I just think it's worth restating that every time it's so easy to say, oh, it's bloated or this or that. None of that's true. The numbers don't lie. It's just an amazing piece of software. But of course, all things can get better. And so I think the JVM, I think Java itself owes its incredible performance and incredible efficiencies to a couple of things. First, the Java programming language garbage collector is a phenomenal piece of software. It allows us to write mediocre code and, get away with it, right? Like, I'm a big fan of the garbage collector. It is amazingly good software. That said, I do take issue with the notion that it is the original Java programming language garbage collector. I think that honor goes to this person. Her name is Jesselyn. She is from the island of Java, Indonesia, and she lives in New York City, and she is the Java garbage collector. Now, again, maybe she's not the first one, but she certainly has a better claim to it than the programming language. And what I love about this is that there are 20,000 likes. There's 20,000 people on the planet that appreciate that joke. The internet is mostly terrible, but every now and then you get something great. So I appreciate that. The Java programming language is really, really amazing because of the Java programming language garbage collector. That's certainly one thing. The second thing, of course, is the just-in-time compiler. The just-in-time compiler does an amazing job. It looks at our code and finds particular code paths that after many successive invocations have actually sort of been executed and will then optimize it by turning it into native code. It stumbles, of course, on certain dynamic things like reflection and serialization and proxies and whatever. Anything that kind of violates the closed world assumptions that it needs to be sure about what the sort of optimizations that it wants to make, it has a little bit of trouble. But basically, for large swaths of your program, it can optimize the program into native code. And it does a really, really good job. In fact, large organizations take their Java program and they let loose production traffic, sort of production-like traffic in a small sort of isolated area, and then they force the JIT to run, and then they release that program into the wild. This is what Google and Alibaba and other large organizations have done in the past, certainly. Okay, so it's a really, really amazing thing. But one wonders if this is such a good deal, if the result is so obviously a good idea, why not just proactively turn it into native code? Well, this is an ahead-of-time compiler, and obviously these days there's a great way to do that. It's called GraalVM. Okay, but GraalVM is just an open JDK distribution with some extra niceties, some really amazing extra niceties. And one of them is a native image compiler, but it too has some trouble with these very dynamic things. Okay, and there is an escape hatch. There is a way out of that. You can automatically, you can sort of like write this configuration as JSON files, okay? And these JSON files, you write a JSON file for reflection and for serialization and for whatever, but I have a couple of problems with this. First, I don't like the word JSON. It just sounds dumb. I don't know how people look at themselves in the mirror and say this out loud publicly. JSON. Just dumb. So I speak French. In French, you'd say a JSON. Much cooler. Can we agree? Yeah, okay, obviously. But I was just in Taipei, and there they speak Hokkien, like that, and they have the word Jingsong, which means happiness. So either way, whether you're Team Jisong or Team Jingsong, I agree. I think we can agree. It's much better than that, okay? I don't know what team you are on, but certainly we can do better. That's part one. Part two is there's just a lot of it. There's just a lot of JSON required to make this typical program work. So I don't want to write that. Thankfully, there's a new feature in Spring Boot 3.0, which came out last November, it's an AOT engine, and it will adaptively sort of write this JSON for you, right? So we're going to go ahead and kick off a native image compilation here. Okay. I'll say Maven skip test, because I didn't write any. P native compile. Okay, and we're just going to let that run in the background. And, the problem with this, of course, is, well, it does take a while. It does take a while. And this is my least favorite part of the process. The results are phenomenal. They're really phenomenal, but it does, unfortunately, take a while. And it's gotten to the point now where I get a little restless, I don't know about you, but when I get stuck at something, I have an inflection point where I'm just sort of sitting there waiting for something to happen. And I almost wish it was longer, right? If it was longer, then I could go take a walk or make a cup of coffee or go to the bathroom or something. But it's not long enough to do that. But it is also long enough that I'm just sort of, I hit a dead end. I'm just sort of stuck there, right? I don't know. It just gets weird. I get bored. I get very bored and restless pretty quickly. And it's gotten to the point where now I understand this XKCD cartoon, right? This is the famous XKCD cartoon about compiling, which asks the question, or posits rather, that the number one program excuse for legitimately not doing your work is my code is compiling, right? Hey, get back to work. Compiling. Oh, carry on. I get this joke now. I thought this was like a C++ people problem, right? I didn't know it was us as well. 2023 is a weird year, but here we are, right? So I didn't want to get this joke, but I do now, right? And it's a bit of a problem because again, I just get very bored and I start to hear game show theme song music or elevator music. You know what elevator music is? That interminable music you get stuck listening to in an elevator when you're just trying to get to your floor and there's 5 people coughing at you in the same elevator for some reason. That kind of music. I don't like that elevator music. And at some point I thought, well, if I have to listen to it in my head, wouldn't it be better if everybody could listen to elevator music? And so I went to Oracle and I said, buddy, friends, please play elevator music during the native image compilation process. And I got some great responses. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do. I really appreciate it. They're doing amazing things, and we're all very lucky. But then I got some great responses. First of all, this one from our friends over at Red Hat. This is from, hello. This one right here, this is from our friends over at Red Hat. Andrew Din, a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, Byteman project lead, and Graal developer. So clearly, this was a great use of his time. And so he responded with this. He says, please, can you make it this elevator music? I'm not going to play it because I don't think I can, but basically it's a soundtrack from the first Pierce Brosnan outing as James Bond in the 1990s when he did GoldenEye. There was a Nintendo 64 video game, and then the video game had a soundtrack, and this is one of the tracks on the soundtrack. It's great. It really is proper elevator music. So well done, well spotted. I like that suggestion. Thank you, Andrew. Somebody else said, I would add that using beeps in general, not only for native image, really helped me to reduce development time. Yeah, that's a great idea. My stupid rice cooker makes a ding sound when it's done. Why can't my multi-million line compiler? That makes a lot of sense. That's an obvious win, right? Clearly a good idea. I'm all about that. But then I got this response from our friend Fabio Niepaus. He's a doctor. He's another one of my favorite doctors, along with Doctor Who, Dr. Strange, Dr. Seuss, Dr. Subramaniam, Dr. Sire, Dr. DeVolder, and Dr. Pollock. And he's a researcher on the GraalVM team at Oracle Labs, a doctor, and previously at these places. And he said, Thank you for your feature request, Josh. The problem with playing music during the native image compilation is that it's just fixing the symptoms. And we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Okay. Anyway, he continues, I have prototyped the --Josh long mode. So let's go see what that looks like, okay? So the way this would work is you would make the request. Can you see that up there? It says native image. It's not very clear. Let me see if I can play it in the, here we go. Yeah, there we go. So that's not much better, but there you go. It says native image, right? Native image --Josh long mode. And then it would print out music brought to you by Josh Long. Now, don't let the fact that this is a picture stop you from understanding and appreciating that you're listening to music at this point, right? There's music playing. That's the whole point. So you got music, and it says music brought to you by Josh Long, but you're still waiting. You're still waiting for that thing to compile. You want something to look at, right? So then you scroll down and you get this, right? You get that. Now, this is, I think, the feature we all want, right? There we go. There we go. This is great. This is what I'm sure it'll get merged any moment now. I don't know when, but soon, right? So anyway, I forgot what we're talking about. Oh, the compilation. Right. Okay. So we go back here, close that. Okay. There it is. Okay. So it took about 1 minute and 13 seconds. So it was done like a week ago. Let's go back to here. Okay. We're going to run the service. Okay. Ta-da. Oh, okay. First problem. It's already being used. The port's already being used. So we're going to go ahead and stop this. Here we go. Second problem. Okay, remember, we used Testcontainers. We're doing git clone run. There's no data source. I didn't have to specify in my property file, I didn't have to specify Spring data source, URL, username, password, all that kind of stuff, right? So the thing is, I need to specify that. So I have a script here, desktop talk cat run.sh, and I'm going to export the environment variables, the properties, all that kind of stuff to connect to a Postgres instance, which I'm going to start by using Docker Compose. I've got this file here, Docker Compose. Okay, and so yeah, you can see it. There's the Docker Compose file. It's going to spin it up, and then I'll just go to the desktop here, cd desktop talk, and I'll say run. That's the program. There we go. It's up and running. Got virtual threads, got native images starting up in 0.13 seconds, got full observability, full web server, full data access technology. All that's very good, but I don't really all that much care about startup speed, unless, of course, you're working in like a Lambda context or something, in which case, use Spring Cloud Function and GraalVM. It's awesome. But what I care about is this. This is the process identifier, okay? And I want to measure the resident set size. So resident set size memory. And basically, Vaadin, of course. Thank you. This is it's RAM. It's the measure of how much memory a process is consuming, and it's measured typically in kilobytes, right? So you divide by 1,000, okay? So I've got this number. PS minus O RSS there. So, 117 megabytes is basically how much my application is taking. Now, I don't know how much your application is taking in production, but I'll bet it's a far sight worse than that. And in fact, I'll go one further. If you're running Chrome, guaranteed you're taking a lot more RAM to serve one page than this is to handle production level traffic with unparalleled scale and lightning fast startup time. It's a great time to be a Java developer, my friends. Okay, so we've got this service. It's up and running. I think we're, pretty good, but I want to build a quick client because we do have like 10 minutes, right? That's a long time. So let's go ahead and build a new application. We're going to go back to start.spring.io. Here, I'm going to build another service. I'm going to call it client because, again, really good with names, okay? So we're going to call it client. We use Java 21. We use Maven. Great. And this time I'll use 3.20. We're going to use the reactive web support. We're going to use the Spring Cloud Gateway and the GraphQL endpoint, okay? We're going to hit generate, and this is going to be a backend for a front end or a API gateway or an edge service, okay? And what you would do here is just handle client-specific concerns, things like routing, security, all that kind of stuff. So I'm going to let it load. What could go wrong? Please, Wi-Fi, faster. Please. Oh, thank goodness. Okay. Service port 9999. Very good. Okay, so we're going to build a client, and in order to do that, you can imagine what I might do here. First of all, maybe I just want to do some generic cross-cutting kinds of things. In which case, I can just create an API gateway. So route locator gateway, right, like this. route locator builder RLB, return RLB dot routes dot build. And what I'm going to do is I'm going to define routes. I'm going to say when the route comes in, proxy, send it onward to localhost 8080/customers. But the problem, of course, is the path of the incoming request is .proxy, and the path of the outbound destination is customer. So I want to change that, and the way I do that is I use a filter, okay? So I can say customers. Very good. And the filters are the real power of Spring Cloud Gateway. I can do things like retry. I can do rate limiting, right, like this. Okay, I can do JSON to gRPC, right, like that. You can do all sorts of things here to sort of make it easier for the outside world to talk to your downstream services without you having to change those downstream services, okay? I can do circuit breakers. You can do all sorts of things, but all I really care about is adding CORS support. I can say HTTP headers dot allow control, access control, allow origin, and then so on, okay? So we can go ahead and restart this, or just start it, I suppose. Here we go. Now, this is a okay, there we go, up and running. Go to the client, or the browser rather, 99.99, proxy. Good. So there we go. So I made the call to localhost proxy, curl -v. You can see I got the same JSON data, but I've got access control allow origin. So I'm able to easily add things to the request without having to change the downstream service. Gateways are great for these common cross-origin kind of, cross-cutting kinds of things, okay? So this is great if you want to act on the envelope of the request, but not the actual request payload itself. If you wanted to work with the data itself, well, you know what you need to do. You need to build a simple client, okay? So customer HTTP client, and maybe you can use the reactive web client or something like this, the non-blocking HTTP client. You can do that, and maybe I'll create a method here to return a customer. But we've got already our first problem, don't we? See that type? It doesn't exist. So I'm going to do something terrible, something that you should never ever do. I'm going to copy and paste code. We'll go back here, take that type, paste that here, voila. Okay, so now I've got my record. I got my object, but this is still too a lot of work. This looks suspiciously like work. I much prefer to avoid that. So instead, we're going to use a new feature in Spring Framework 6 and later to support declarative interface-based clients. We had this in Spring Cloud, but that support has now been pushed down into the framework. So now I can describe an interface, and then I can create an implementation of that interface using the new abstraction. And this works for HTTP and for RSocket, and conceptually we can add more as well, and it's the same machinery. So builder for web client adapter for client, passing in the web client, right? So var wc. We're going to inject the builder here. So web client dot builder, voila. Base URL HTTP localhost 8080, okay? Dot build. There we go. Pass that in. wc dot build. Oh, thank you. Oh, mob programming. I love it. Thank you. Create the client customer dot class. Okay, there's my implementation. What might I do with that? Well, maybe I'll inject it. Okay, I can use that. Voila. And I can say, okay, when the application starts up, make the request, get the results, and then enumerate them here. So I'm going to go ahead and restart the application. Okay, compile away. Saving caches. What does that mean, IntelliJ? Okay, good. So there's the data. It worked. Good stuff. Now, I don't normally just create a client just so I can print out some data when the program starts. What I want to do is I want to use that to create a new view of the data. And here, my friends, why would you do that? Well, a lot of times you might have different back-end microservices that are, sort of separated out into small, singly focused things. But I want to create a new view of them to, to satisfy some use case by my clients. And when I say clients, I mean iPhone devices and PlayStations and Chrome browsers and Android devices and whatever. That's a very important use case there, right? Remember, as much as we want on the back end to tease our services out into small, separately, independently focused things, the clients want everything at the same time, right? So they want everything at the same time. They don't want to pay the bandwidth cost of transmitting extra things beyond what they need, and so on. So we need to sort of meet them where they are. And one great way to do that is to use GraphQL. So I'm going to use the Spring GraphQL support. I'll go to source, main, resources, and I'll create a new file here called schema.graphql QLS, okay? And I'm going to describe a type, like my type is called customer, right there. And I'll have a name. So this is the type that's in my domain. And then in order to export these endpoints, I'm going to describe a query. And this is going to have, it's a well-known special type where the engine is going to look for attributes, that's this, that it can export to be consumed by the consumer, by the outside world. And it's going to return a collection of customers, okay? So customers by name, string like that, returning an array of customers. Whoop, here we go. So I've got these two different fields, these two different things that I need to actually implement here, okay? And I'm going to do that by just repurposing that declarative client that we just spent so much effort building. Okay, here we go. Name, publisher, customer. Okay, come on, customer, customers by name, path variable, string name, and then we're going to build a controller. We're going to build a GraphQL controller. So customer, GraphQL controller, and it's the same annotation as you've seen for all other kinds of controllers in the Spring ecosystem. Remember that annotation lives in Spring Framework itself. It has no coupling to HTTP or RSocket or anything. It's just a generic annotation. So we're going to say that this endpoint called query mapping, this endpoint is going to be responsible. It's going to get invoked whenever it's time to produce a response for the attribute called customers. Okay. So we'll say this.http.customers. Great. And then same thing here. We're going to say query mapping, publisher, customer, customers by name, and then we're going to pass in an argument of type name here. Okay. So return this.repository, or this.http rather, dot customers by name, etc. So I'm basically just forwarding to that declarative interface I built. Okay. Now I want to try this out. So I'll go back to my config here and I'll say GraphIQL. That's a console. I'm going to go ahead and reload the program just to take advantage of that. Here we go. Good. So go back to the console here. Localhost 9999 GraphIQL. Okay. Take your time. There we go. Good. We have a declarative console we can use now to interact with our service. So I'll create a query, get all the custom. Oh, did I call it customer? I did, didn't I? Customers. That's better. Let me restart that. Okay. And then refresh. Now you can see I've got the compiler helping me out. I can ask for as much data or as little data as I want. I called the customers endpoint, but what if I want all the customers and their name and the value by its name? Okay, great. Do that. ID, name, hit refresh, etc. And this is nice. I didn't have to make two different network calls to get all the data for both the name and the customer's endpoint, right? I got this and this at the same time. And this is already this is a win compared to having to make two different calls to two different services to get data to feed the data that has to load. Now I just make one network call and I get everything I need up front. That's better, but what if I wanted to introduce another service, okay? Imagine I had another microservice. I don't, but imagine I did, that produced profile data from another microservice. And this is, I'm going to change the schema now to have this profile. But of course, I didn't add a profile to my backend implementation for the customer. So I'll do that here. I'll say @ID, and now each customer has a profile, right? Profile. There we go. And what I want to do is I want to make sure that when somebody gets the customer data, if they ask for the profile, they can also get that as well. So I'm going to say that the type I want to resolve for the root of the aggregate is called customer. And I'm going to return a profile object by injecting the customer for the aggregate, right? So I'm not making a network call across the wire here, but imagine I was, right? So getting profile for customer, blah, okay? Customer.id, Command-Shift F9, go back here, refresh, okay? And, oh, did I not reload it? Oh, I did a live reload instead of I didn't have DevTools configured. We'll restart the hard way. Okay. Okay, paste. There you go, profile. Okay, so now when I ask for a profile, I get the ID back. Down here, same thing, I get all the profiles back, etc. So it's easy with this arrangement to sort of add new objects to the graph, to create a new unified view of the data, and so on. So my friends, we've looked at just a few things today that hopefully you can use to build better, more scalable, more efficient, more memory efficient, more robust services that are worthy of production. We've only just begun to scratch the surface. Remember, it's 2023, but I fully expect that in 20 more years we'll be here having just an amazing old time talking about the next big thing. My friends, who learned something new? Good stuff. Who had fun? Okay, very good. I had fun too. Please don't forget to vote. Thank you so much for being here. Have a great DevOps. I appreciate you. Bye-bye.